China is officially entering a new era, an era that just a few years ago many considered science fiction, an era in which humanoid robots are gradually ceasing to be laboratory experiments and are beginning to become a fully integrated part of the economy of the world's largest manufacturing power. In recent months, global media attention has been focused on the Chinese company UB Tech, which has introduced a new generation of humanoid robots in the U1 series. Their emergence has created major global attention not only within China, but far beyond its borders. Analysts describe this development as the beginning of a new industrial revolution, comparing the significance of humanoid robotics to the rise of the internet, smartphones, and artificial intelligence. For decades, humanity has dreamed of creating a machine capable not only of executing individual commands, but of fully interacting with the surrounding world in the same way a human does. A robot that can see, understand speech, analyze its environment, make decisions, and perform complex tasks in real physical space. For a long time, such projects remained purely scientific experiments. However, today, the situation is changing rapidly. According to forward-looking forecasts from several research institutions, China may become the first country in the world where humanoid robots begin to be deployed at scale, not as isolated demonstration projects, but within the real economy in the coming years. The reason is simple. China has the largest manufacturing base on the planet, enormous computing capacity for artificial intelligence development, and vast financial resources for implementing new technologies. The emergence of the U1 series is seen by many experts as a symbol of this transition. The new generation of robots has been designed with a form that closely resembles the human body. Their height is comparable to that of an adult human. They are capable of maintaining long conversations, recognizing the emotions of people they interact with, analyzing their surroundings using dozens of sensors and cameras, and adapting to new situations through advanced artificial intelligence systems. But the most interesting aspect is not their appearance. The main question being discussed today by investors, engineers, and governments around the world is different. What happens if such robots become cheap enough for mass production? Imagine China 10 years from now. Massive logistics centers where thousands of humanoid robots sort cargo around the clock. Factories where most routine work is performed by autonomous machines. Hotels, shops, airports, and hospitals where a significant share of tasks is handled by next-generation intelligent assistants. For the economy, this could mean a sharp increase in productivity and a reduction in costs across almost all sectors. Some futurists go even further. They suggest that after reaching a certain scale of production, the cost of a humanoid robot could fall so much that it becomes affordable for ordinary families. In that case, the robot would no longer be industrial equipment and would instead become a household device, much like computers once stopped being tools of large corporations and eventually entered almost every home. However, alongside these opportunities come new risks. Regulators in different countries are already discussing future laws that should define the rights and responsibilities of owners of such systems. Who will be responsible for the actions of an autonomous robot? What data will it be allowed to collect? How deeply will artificial intelligence be allowed to participate in decision-making? Where is the boundary between a useful assistant and a technology capable of reshaping the labor market beyond recognition? The issue of employment is particularly serious. Economists warn that the mass deployment of humanoid robots could lead to the largest transformation of the labor market in modern history. Millions of professions may change. Some jobs may disappear entirely. At the same time, entirely new fields of activity will emerge, fields that do not yet exist today. History shows that every technological revolution has created more opportunities than it has destroyed, but the transition period has always been accompanied by significant disruption. This is why many observers believe that the race to develop humanoid robots has already become a new technological competition between the world's leading powers. China, the United States, South Korea, Japan, and Europe are investing billions of dollars into the development of artificial intelligence and robotics. The winner of this race could gain an enormous economic advantage for decades to come. If the predictions of technology advocates prove correct, then the current generation will witness one of the most profound transformations in the history of civilization, a transformation that will not begin with the emergence of new smartphones or computers, but with the appearance, alongside humans, of intelligent machines that are visually almost indistinguishable from people. At the same time, the most interesting question may not even be how many robots China will be able to produce. A far more important issue is what will happen when these machines begin to learn from one another. Today, most modern artificial intelligence systems are already capable of analyzing enormous volumes of information, identifying patterns, and improving their skills far faster than humans. If such intelligence is combined with the physical body of a humanoid robot, a completely new situation emerges, one that humanity has never faced before. Imagine a vast network of millions of humanoid robots across China. One robot learns a better way to sort goods in a warehouse. Another discovers a more efficient method of serving customers in a hotel. A third learns how to repair industrial equipment more quickly in a factory. Thanks to cloud technologies and centralized learning systems, this experience can be instantly distributed across the entire network. In effect, every new skill learned by one robot becomes a skill available to millions of other machines. This is why some experts describe such systems as a new generation of collective intelligence. A human learns over years. A robotic network could potentially learn across an entire country in a matter of hours. If such a model truly works in practice, the speed of technological progress could become dramatically higher than anything seen before. Special attention is currently being paid to the cost of such devices. According to several analysts, price will be the key factor determining how quickly humanoid robots spread. Early models are always expensive. It was the same with computers, it was the same with smartphones, it was the same with electric vehicles. But history shows that once mass production begins, the cost of technology tends to fall rapidly. Many investors are already drawing parallels with the early 20th century automotive industry. At that time, cars were considered a luxury for the wealthy. No one could imagine that within a few decades, millions of people would own their own vehicles. Today, similar discussions are emerging around humanoid robots. Some forecasts suggest that in the future, the price of a basic model could become comparable to that of a modern mid-range car. If such a scenario materializes, the consequences would be enormous. For the first time in human history, every family could potentially afford a helper capable of performing dozens of different tasks. House cleaning, cooking, caring for elderly relatives, childcare, home security monitoring, appliance maintenance, shopping, and delivery could all gradually be transferred to robotic systems. For China, this development has particular importance. The country is facing an aging population. The number of elderly people is steadily increasing, while the number of young workers is declining. This demographic challenge is considered one of the main threats to long-term economic growth. As a result, robotization is increasingly seen by many Chinese strategists not merely as a technological project, but as a tool for maintaining the future competitiveness of the economy. According to some estimates, China could face a shortage of millions of workers across various industries by the middle of the next decade. Humanoid robots are viewed as one possible solution to this labor gap. If a machine can perform human work around the clock, without vacations, sick leave, or weekends, its economic attractiveness becomes obvious to businesses. However, this is precisely where the most difficult questions begin. What will happen to millions of people whose professions are threatened by automation? What will cashiers, warehouse operators, logistics staff, administrators, consultants, and dozens of other professions do if a significant share of their responsibilities is taken over by machines? Some experts believe these concerns are overstated. They remind that every technological revolution has been accompanied by fears of mass unemployment. When tractors appeared, people feared the disappearance of agricultural professions. When computers emerged, many predicted a catastrophe in the labor market. But in the end, the economy adapted and created new jobs. Other analysts take a more cautious position. In their view, artificial intelligence and humanoid robotics differ from all previous technologies in that they are, for the first time, beginning to compete not only with human physical labor, but also with human intellectual capabilities. This means the scale of change could be significantly more profound. Equally important remains the issue of regulation. Governments in many countries are already discussing possible restrictions on humanoid robots. It is necessary to define rules for their use in public spaces, safety requirements, standards for personal data protection, and mechanisms of accountability for the actions of autonomous systems. The more realistic robots become, the harder it becomes to distinguish a human from a machine. And this factor alone could generate numerous new social and legal problems. Imagine a situation where in a shopping mall, airport, or hotel, there are dozens of next-generation humanoid robots around you. Externally, they are almost indistinguishable from humans. They are able to hold conversations, recognize emotions, joke, help solve problems, and interact with people in a highly natural way. For most visitors, it may be extremely difficult to determine whether they are dealing with a human or a machine. Some futurists believe that this moment will become a psychological turning point for society. Humanity will, for the first time, encounter beings that look like humans, behave like humans, and speak like humans, but are not human. And no one yet knows what the long-term effects of such coexistence will be. Therefore, many observers are convinced that the story of humanoid robots is only just beginning. Perhaps in a few years we will look back at today's models in the same way we now look at the first mobile phones of the 1990s. They will seem slow, expensive, and primitive compared to what comes later. But they may become the starting point of a new era. An era in which artificial intelligence first gains the ability to exist not only inside computers and data centers, but also directly alongside humans in the physical world. But if we look even further into the future, it becomes clear that this may not simply be a new economic sector. Many researchers believe that humanoid robots are capable of changing the very structure of society itself. Today, most people perceive a robot as a tool, as a machine that performs a specific task. However, as artificial intelligence continues to evolve, this boundary may gradually begin to blur. Leading laboratories around the world are already working on artificial intelligence models capable of reasoning, planning multi-step actions, and independently finding solutions to complex problems. If such systems are integrated into future generations of humanoid robots, their capabilities will extend far beyond merely executing pre-programmed instructions. They will be able to learn new skills on their own, adapt to new conditions, and become more useful with each day of operation. This is why some analysts argue that the real revolution will not begin when the first millions of humanoid robots appear, but when they become intelligent enough to perform most domestic and professional tasks without constant human supervision. At that moment, the economy could experience an unprecedented surge in productivity. Companies will be able to scale much faster, the cost of many goods and services will begin to fall, production capacity will increase, and access to technology will become even more widespread. China fully understands the importance of this race. That is why the state and the largest technology corporations continue to invest enormous resources into artificial intelligence, robotics, and computing infrastructure. Many believe that the next 10 years will be decisive. The country that first succeeds in building a large-scale ecosystem of intelligent humanoid robots will gain a colossal advantage in the global economy. Today, all of this may sound like science fiction, but not long ago, smartphones capable of answering any question, self-driving cars, or artificial intelligence that can write texts, generate images, and program software also seemed like science fiction. Technological progress rarely develops gradually. More often, it remains invisible for a long time and then suddenly accelerates so rapidly that society simply cannot keep up with it. And if such a scenario does indeed materialize, then within a few decades, historians may describe the present period as the birth of a new era, an era in which millions of intelligent machines first appeared alongside humans, capable not only of executing commands, but also of actively participating in the economy, industry, and everyday life. And then, the unveiling of the first realistic humanoid robots may enter history in the same way as the first automobiles, the first computers, and the first internet, because it is precisely such events that sometimes mark the beginning of changes that ultimately transform the entire world. Another aspect of this story, which is discussed significantly less today, but may turn out to be even more important than the technology itself, is global competition between countries. Over the past 200 years, global leadership has been determined by access to industry, resources, energy, and computing technologies. However, in the near future, this list of factors may gain another key element: the number of intelligent humanoid robots. Some strategic analysts already refer to future robotic systems as a new equivalent of industrial power. If in the past a nation's economic potential was measured by the number of factories and workers, then in the future, one of the key indicators may become the number of autonomous machines capable of performing real work. A country with millions of such devices would effectively gain an additional workforce of unprecedented scale. Imagine a situation where a large manufacturing complex is able to operate almost around the clock. Robots do not get tired, do not require long rest periods, can work at night, and quickly learn new operations. This does not imply the complete disappearance of humans from the production chain, but rather a fundamental shift in human roles. People will increasingly focus on management, design, quality control, and the development of new technologies, while a significant portion of physical work will be transferred to machines. This is why many investment funds already describe robotics as the next multi-trillion-dollar market. As artificial intelligence continues to improve, demand for humanoid platforms may begin to grow across virtually all sectors of the economy: logistics, healthcare, construction, agriculture, hospitality, infrastructure maintenance, energy, and manufacturing. The list of potential applications continues to expand. One particularly interesting scenario is in the field of elderly care. For many countries, this is becoming one of the most serious social challenges. Populations are aging, while the number of care professionals is growing much more slowly. Humanoid robots could theoretically take on part of these responsibilities. They could assist people with mobility, remind them to take medication, monitor health conditions, and contact doctors or family members in case of emergencies. Some futurists believe that this area will become one of the first mass markets for humanoid machines. Unlike industrial sectors, where robots must compete with existing automated systems, demand in elderly care continues to grow rapidly. As a result, the potential demand for such assistance could be enormous. However, the more capabilities machines gain, the more frequently questions of safety arise. What happens if malicious actors attempt to gain access to the control systems of such robots? What if an autonomous machine makes a wrong decision? What mechanisms must exist to prevent such scenarios? These questions are actively being discussed by engineers and regulators around the world. Equally important is the issue of data privacy. A future humanoid robot will quite literally be present alongside a person every day. It will hear conversations, observe its surroundings, analyze the owner's behavior, and interact with their digital ecosystem. All of this creates an unprecedented volume of information. That is why many experts believe data protection will become one of the central issues of the new robotic era. At the same time, artificial intelligence technology itself continues to evolve. Modern models are becoming increasingly capable of reasoning, analysis, and solving complex problems. Just a few years ago, AI systems could perform only narrow sets of tasks. Today, they are already able to write texts, analyze documents, generate images, program software, and assist in scientific research. If development rates remain unchanged, future generations of intelligent systems will become significantly more powerful than today's. It is precisely here that the boldest hypothesis emerges. Some researchers suggest that one day artificial intelligence may surpass humans in most intellectual tasks. If such a level is achieved and integrated into humanoid robots, humanity would face a fundamentally new reality. Machines would be able not only to perform work, but also to participate in the development of new technologies, the design of complex systems, and the solving of scientific problems. Proponents of this scenario believe the result could be a dramatic acceleration of technological progress. More advanced robots would create even more advanced robots. More powerful artificial intelligence would help design new generations of artificial intelligence. The pace of innovation could increase many times compared to today's level. However, Critics remind us that there is often a vast gap between impressive demonstrations and real-world deployment of technologies. History contains many examples where revolutionary inventions required decades to achieve mass adoption. Therefore, even the most optimistic forecasts should be viewed with caution. Nevertheless, one thing is already clear. The world is truly entering a period of the largest transformations in robotics in modern history. Companies are investing billions of dollars. Governments are launching national support programs for the industry. Semiconductor manufacturers are expanding production capacity. Developers of artificial intelligence are creating increasingly advanced models. And all these processes are gradually merging into a single technological ecosystem. Perhaps within a few years, the appearance of realistic humanoid robots will no longer surprise people, just as smartphones, the internet, or satellite navigation do not surprise anyone today. But right now, we are witnessing the very moment when the technology stands on the boundary between experiment and mass adoption, a moment that may later enter history textbooks as the beginning of a new technological era. And if development continues at the current pace, one day millions of intelligent machines could indeed become a normal part of everyday life. They will work in factories, assist in hospitals, maintain infrastructure, support elderly people, perform dangerous tasks, and take over an increasing amount of routine work. Humanity will then be forced to redefine its role in a world where systems capable of thinking, learning, and acting increasingly independently exist alongside it. And this question may become the central challenge of the 21st century.